do a solid revolution using GeoGebra. So please search for GeoGebra using Google, and we are going to click here where it says Calculadora 3D. Okay, here you will see a different setup than what we are used to. Why? Because we are going to see the 3 dimensions. We are going to see X here in red, Y in green, and Z. That is the 3rd dimension that we're going to use right now for us to rotate our function. Okay, so the first thing that we are going to do is go to settings and remove the plane so we can see exactly what we're doing, and then go to propiedades and put this for it, the y-axis for it to be vertical, so it's the same view that we're used to. And if you want to, we can go down here and put grande for it to be bigger. Okay, so once we have it set up like this, if you see, it changed. Now we have y here and x here. The colors remain the same, but in here we can see it more clearly. So I'm going to do an example of what you did in part 1. So for example, what we had was a function that we can call it x plus 2, and then we delimit that we constrained the domain. So it was 0 from x to 2. Okay, there we have it. Now we are going to rotate this. Okay, so for me to rotate it, I need to put the angle. What is the angle? As it's 360 degrees or is 2 pi, I'm going to declare it. How am I going to call it? I'm going to call it n. N equals to 2 pi. If you write pi, it's changed automatically. 2 pi. So now we are going to use a command of GeoGebra that is called superficie. Okay, superficie, and we are going to write f, because we are using the f, the f function. There's no need for us to write down f of x. It's only f, then comma, n, that is the angle that we are going to use. And if you see clearly in here, it's already rotated around the x-axis. Okay, if I click enter directly, I'm going to see this eje x, because it automatically rotates it about it. Okay, now in here I know that you have at least 5 sections. So what am I going to do next? Well, to add the next section. In my case is 1/2 of x minus 2 squared plus 4. Okay, that is the function that follows. And I'm going to constrain the domain from 2 to 4. Great. Okay, and I'm going to repeat the process. Superficie, I open parentheses. In here it's only telling me the syntax it needs to have. I'm writing g because the new name of my function is g, comma, n, the same angle, enter, and it rotated again. Okay, so if I right click it and slide it, I can see my solid of revolution as it's forming. Yay! So that's what we want. Okay, we want the entire object to be modeled. Now, what happens? Well, this is the first way to do it. Hopefully you don't have any doubts by now. It's really easy if you see. The other way is for us to do a piecewise function. So I'm going to do the same thing that I did before. I'm going to hide this for us not to get confused. And in here, I'm going to declare another function, the same one for you to see the same result. From 0 to 2. And in here, if you see, I have only one function, nothing has changed. If I click it, it says C. Why C? because it's the interval where the function behaves like x plus 2. So I'm going to add another function, okay? Adding first the interval. So in this case is 2 from 2 to 4, and my function is the same, 1/2 of x minus 2 squared plus 4. Okay, what changes here is, if you see, is the same figure, okay, the same figure that we had before, but now it behaved like a piecewise function. So you can do all of that. The only thing that changes is that you are going to write down all of the different intervals followed by the function it is working on. Okay, I know that your functions may have a decimal coefficient, so please make sure to use a little amount of decimals, depends on what you're doing, for it to be easier for you to manipulate them later. Okay, and then as I have it as a piecewise function, the only thing that I need to do here is again to use my superficie command and write h, comma n, enter, and it rotates it automatically. Okay, so the difference is that if I do it as a separate function, I need to add the superficie command each time, and if I use it as a piecewise function, I only need to add it once. Okay, so the result is the same, so you can choose which is better for you. Have a great day. Hopefully you don't have any doubt.